Hello everyone, my name is Toroyan Inessa, and today we're going to discuss third homework of the course Database Systems, which is about normalization. So I will share my screen right now. And this is it. So first problem asks the following. So we're given this relation R and this functional dependencies. The first task is to find the minimal cover. So thus we have three quick steps. First of all, we simplify the right-hand side. If we have something like A goes to BC, let's say, so we have more than one value here, then we can simply divide it by 2. So it becomes A goes to B and A goes to C. That's it for the first step. For the next step, we need to simplify the left-hand side. But the thing is that we cannot do the same trick as we did for the right-hand side because let's say if we have this one, AB goes to C, we can't just write A goes to C and B goes to C because their combination goes to C. But in this particular case, so we know that A goes to C by itself. And we know that B goes to C by itself. So in this particular example, this really is redundant because if A goes to C, then if you add B, it doesn't change anything. So we can just get rid of this in this step. So we get rid of it, and here you can see we have 7 functional dependencies. Here we have 6. And I also modified this part. AC goes to D. So we can remove from here A because with C, let's check that I can obtain C, I can obtain A, I can obtain B and D. Thus, I don't need A here because it will not change anything for us. Yeah, so we'll have this in the second step. And the last step is to remove redundant some redundant functional dependencies, and which are those? So let's say we have this duplication, A goes to B, which we don't need at all, so we can simply remove it. Other than that, we have this. So we have that A goes to B, we have that B goes to C. And from this, we can derive directly that A goes to C because of this property that is called transitivity. And this means that we do not need to explicitly specify this functional dependency. And we remove these 2 lines, and we are left with these 4 functional dependencies, which is exactly our minimal cover. The next question asks us to find all the candidate keys of the relation R by determining the closure of the attributes. So closure is what? It's simply said, what can we obtain with whatever we take? Let's say we take A, and we need to determine what I can obtain with it. I can obtain B, I can obtain C, and from C, I can obtain D, and from A, of course, I can get A. This means that with A, I can get all the things that I have, and so this is equal to R, and this means that A is a candidate key by itself. The same with B and C. We can obtain whatever we want. Let's just try with C. So with C, I can obtain C. I can obtain A by this relation. I can obtain D by this relation, and I can obtain B due to A. So I get A, and with A, I get B. And the last one is D. So with D, I can obtain only D because I don't have anything from left-hand side that is D as well. And actually, when doing this, we can also consider some combinations. Let's say AC or DB, but in this case, we do not do it. Why? Because we already know that A, B, and C are candidate keys by themselves, and there's no sense to consider A, B, let's say, because A is already a candidate key. And why do we not consider anything with D? Because all of the rest of our attributes are candidate keys. If we had some more thing, let's say we had an E, which was not a candidate key. Let's say we had something like this, for example, then we could consider DE. Why not? But in this particular case, we do not have it, unfortunately. So this means that we have 3 candidate keys, A, B, and C. And this is the end of problem 1. Okay, problem 2. We're given a musical group relation with the following functional dependencies. And a problem asks us to convert it to 3NF. So 3NF is the third normal form, which has some rules that we need to follow in order to make our dependencies appropriate according to 3NF. So first step is to find the minimal cover. How to do it? The first step was to simplify the right-hand side, and we just go ahead with group name gener and group name date founded as 2 separate functional dependencies. And the last one is fine for the first step. For the second step, it's also fine because we cannot simplify this left-hand side. And we do not have any transitivity or redundancy. That's why we're fine. So we have this minimal cover. The second step is to find the candidate keys. So we can consider group name. With group name, I will obtain genera, group name, and date founded. So this is definitely not equal to our R, because we have here an artist's name and a date join that we cannot obtain with this 2. So, this means that group name by itself is not enough. So we can add artist name. So let's check. With group name, I obtained these 2 and group name itself. And with artist name, I obtain artist name, and the combination of this gives me date joined. So means that I have everything and equals to R. So this is a candidate key. Now the last and final step is to decompose it into 3NF. So we just go ahead and take the union of our first functional dependency as an R1 and the second one as well. And everything is fine according to 3NF, because here 3NF says that X goes to Y, then at least one of the following should be satisfied. So either X is a super key, or Y is prime attribute. So what is prime attribute? It is an attribute that is part of our candidate key. So let's see here. So group name is part of our candidate key, and artist name, group name are our candidate key. So super key. This means that we are fine with this problem. We're done, and we can actually move forward. Okay. So, okay, I will better go with control that. Okay. Commends it. Okay, the B says that we need to convert the same to BCNF. So what actually says BCNF? Let's see. So BCNF says the following, that if we have X goes to Y, then X here must be super key or candidate key. If X violates Y, this violates this constraint, sorry, then we will do it with the following formula, where we will get an R1, which is going to be the union of X and Y, and we will have an R2, which will compute with this formula. Okay, so let's see how it works in practice. So the first steps are the same that we did in this previous example. We found this minimal cover, and this is it. We found the candidate key, and now we just need to find something that violates BCNF. So, and the very first one already violated because group name is not a super key for us. And thus, we need to simplify it into two relations. So R1, we take the union of group name, gender, and date founded, and R2, we compute this. We compute it with this formula. So we subtract gender, date founded minus group name from R, and R is actually this all of our properties, these ones that we had. So we are left with group name, artist name, and date joined. So here we obtained these two relations, and the rest is fine. We do not have any violation because here we have group name, which is part of our candidate key, and group name, artist name, which is our actual candidate key. This is it for this B problem. And the very last third one, we're given with the following correlation, and we are given with these functional dependencies. We need to convert it to BCNF using BCNF decomposition, and we need to underline the primary keys of decomposed relations. So let's see. So we have this. First step was to find the minimal cover. So we have model brand name, model body style, serial number, model. So we do not have any problems in the right-hand side, in the left-hand side as well, no transitivity, no redundancy. So we are already given the minimal cover. Now we need to find candidate key from this. So let's try with model. So with model, we can get model itself, brand name, and body style, nothing else. So we covered this one, this one, this one, but we can't obtain serial number with it. Thus, we can try with serial number. So serial number gives us serial number itself, and it gives us model, which gives these two. So we are fine, we get everything. So this is a candidate key, our only candidate key, I would say. So we need to find violations of BCNF. Model brand name is a violation. We see it in the very beginning, and we decompose it into two R's. First one is the union, which is model and brand name, and R2 is we calculate it with the formula that we have. If you remember, it was R minus Y minus X. And when computing this, we are left with model, serial number, and body style. Here, we need to see whether we have any other violations of BCNF. And here, actually, we have a violation. We have model, body style, and we need to again create two more relations from this. So we take the union and we calculate the second one with the same formula. So now we consider this one, and we do not have any violations of BCNF. because X is a serial number is a super key in here. Because if you see in this R22, we have a single relation, which is serial number to model. So this is our X, which is a candidate key. So we're fine. Now to decide which relations we need to take, we take this R22, we take this R1, and since this violated, we divide it into two, then we don't take it anymore. We just take this R1 that we had in this left part, this one. So what we have is serial number model, model body style, model brand name. Actually, yeah, this is the result that our BCNF keeps. Yeah, so this is it actually. In real life, what would be good? I think model determines body style. So if I know what if my knowledge on body style is correct, then we could just come up with such design that we would love. So we would have model. We would have brand name and body style. And this would be like I don't know, car properties. Let's say no, not properties, but models. And this would be the primary key. And the second table that we would design would be serial number to model, which would be a foreign key. But this is like a design that I would do in real life, and it's a bit different than what we obtained in BCNF. So that's it. Thank you very much for watching. I hope you enjoyed it. Bye bye.